Alright everyone, welcome. As promised, I was going to go through the in-class example on linear programming on a video so that we could go through this together. Now, the trick with linear programming is just that you are optimizing some value to improve based on some constraints. So you're optimizing something based on constraints. And if you remember the in-class example is based on this idea that you have some crazy guy who wants to optimize or maximize his or maintain a minimum daily allowance of 5 nutrients while paying as little as possible from variable sources of food. And so we have a table here of how much of these vitamins exist in each one of these species of food and the cost associated with them. So what we're going to do is create a system of comparisons, of equations, that is going to calculate based on what we would get in daily intake if we ate a certain amount or a certain number of servings of each one of these items. So we're going to create a new column of values of what is going to be the actual intake amount of food for each one of these items here. And so we're just going to give it all start with a concept of 1 as our feed place of input. I'm going to just define it this way just so we can have this column set up properly. Servings, intake of food, servings. So we have that. Great. Now, in order to make this work, we would need to know, based on each one of these servings, if we say take 1 serving of rice, that means we're going to get 0 milligrams of thiamine from that, 0 milligrams of riboflavin and niacin, but we'll get 11 micrograms of folic acid, and it'll cost us $0.25 per serving. So we can actually calculate out the total cost for how much we were going to pay for that 1 serving by this times this, and then this times this for the folic acid. Oh, and the niacin will be 4 milligrams. Now we can create a multiplication where we take each intake and multiply it by every one of these items and create a new table of total amount taken in and cost by food. So this is going to be a new calculated table for each one of these species here, rice and so forth, cabbage, peanuts, and so forth. And we can actually copy and paste this down here, and we'll just put this here. And I'm actually going to give us a little bit more space. Insert. Bring this up. I'm going to change this to no fill, and then I'm going to make this whole thing, let's give this a different color just so we can keep things straight a bit. So there we go. We have a new table. That's going to be total intake of food. And what we're going to do is we're going to, oops, I need to move this up. Move this up. There you go. And I'm just going to copy this so it's all the same color. And I'm going to copy this so it's all the same color. This is just to make it pretty. Okay. So now we're going to take each one of these items and multiply every column here. Let's say this rice times this intake. And if we lock that in, I'm just going to lock it in as appropriate here. Hit enter, and then just copy this across. We're going to get the total amount based on the number of servings that we're going to be changing. So if I was to make this a 2, you'll notice it's increasing appropriately and so forth, or 3 or 4. This value is going to be increasing. This is the total amount taken in for that rice. Now, if I was to just copy and paste this down, you'll notice this won't be correct, because here you can see this value, cabbage, isn't related to the total amount of cabbage that's being taken. It's still linked to rice. Why is that? Because the absolute reference here is $2 signs. So we can actually either manually move this down, and hit enter and then copy across, or we could actually readjust this entire equation and change the formatting on this so that here, instead of saying $J, $5, we could say it's $J, which means it will, as I'm copy from left to right, it won't move the cell left to right. But if I leave the 5 open, when I copy down the rows, this will move down with it. So it won't move this way, but it will move this way, which is exactly what we want. So I'm going to say enter there, copy across, copy down, and we have a table now of total amounts calculated by this multiplication. So then we can say the sum of all this, and this will now equal our thiamine intake. And I can copy and paste this across, and this will be total amount here for all of these, right? So this becomes our total amounts that we're taking in. Now, if we want to go ahead and compare these totals versus these values here, which is what we want to do, why don't we actually physically move them down in such a way that we can make sense of this? So in this case here, this first table is thiamine, so I will place this here as thiamine. This next one is riboflavin. I'll make that riboflavin. This is just going down straight down the rows appropriately until we get down to vitamin C. So we just took all these totals. Here, I'm going to put that over here. And this final table here was cost servings. It was from this column here. So I am going to place that down here. And total cost of daily intake. And I'm going to give this a different color. Let's say this is green as the target value. So there we go. And I'll just make this whole thing green. Okay. So this is the value that we really want. I'm just going to format currency so we can know it as currency. And we'll do this one as currency as well. There we go. All right. So you now have this. These are the total actual intake, and this is minimum requirements. Okay. So the minimum requirements is what our target is for intake. We want at least that. Another way of saying that is we want this value here to be less than or equal to this value. This value can be bigger, but it cannot be smaller than this one. So I'm just putting that in there for reference so you can see the comparison we're going to make. So now that we've got this all set up, that these numbers here are actually linked to these values here, which are actually linked to these table and this input table. Same thing with this. All of these are linked values now. Now that we have this all set up, we can actually go to our data, go to solver, and specify our desire. We want to minimize. In this case, we're taking our cost. We want to minimize by changing all these intake values under certain constraints. And you can say subject to the constraints. And the constraints we're going to subject to is these values here are going to be less than or equal to. We could make a change. We could say equal to, greater than, or whatever. But in this case, we just want it to be less than or equal to these columns here. Let's click OK. So now that we have the constraints, now that we have the cells that we're going to change, now that we have the target cell defined, and we know it's minimum, we can click Solve. It said it found its solution. We can look at it, and sure enough, it found a solution for us based on the intake values. Since this is a rather large data set, we can actually change this to round it appropriately. So we'll have add servings and intakes, and we are set up good. So I believe we got a cost, we got the intake, and this looks very good. Alright, so now that we've got this approach done, let's attack this problem from another way. And we can do this exact same problem using a matrix math approach to solve the problem. If you notice, this is just really taking an array of data tables, and instead of organizing them in two steps where we create a second table of totals, sum those totals up and bring it over, we can do it in one step using a matrix approach. So I'm going to do that right now by just deleting all of this and resetting to 0. Let's go back to delete. Delete. Let's go. Okay, and I'll leave this here. This is just our starting cells. Okay. Well, no, I'll leave this here. Okay. So I'll delete this too. Okay. Delete. Left. Right. So here's the starting set of problems. So we're going to create now we want to create a table of matrix approach. Now, in order to do that, it'd be convenient, since this is actually in a vertical column, I would like for our table now to have all of these values vertical as well. So I'm going to take this entire column, table, copy, and I'm just going to transpose it. Go to paste special, and where is the transpose? Transpose. Oh, here it is, right there. So now we have this nice table of values where the types of food are along this direction, and all our essential minerals and so forth are in this direction. Great. And so we have that. Nice. Now we can create our vector and our x vector. So if we're going to put this in matrix notation, we are going to say ax is equal to b, right? So we need an x vector that is our unknowns. In this case, it's going to be our serving size. Serving size. The size of this x vector has to be the same size of this, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need serving size table 1, 2, 3, 4, 5, 6, 8, 9, 10. So this is going to be our serving size vector for our table. Insert, and it's home. Go to fill this in as yellow. And for sake of labeling, let's say copy, and we'll transpose this that direction. Great. And we'll fill the formatting only. Oh, undo. Should say fill formatting only. There we go. So there you go. Now we have two separate vectors that we're going to want to play with, and I'm just moving things around a little bit. We have a cost vector here that we're going to want to create a total cost. This total cost, and I'm going to start labeling these columns appropriately. If this is our x vector, then I'm going to define this as our cost vector. Okay. And then I'm going to define this as our A matrix, because all of these are the coefficients that we're going to multiply by our servings. So here I can create I can create now our total intake as this term here, AX times AX B, and this is our ideal B column. So here we just need to do mult, and we're going to take the A matrix, which is this. Oops, yeah, select the entire range. Make sure you do that. mult, select your A matrix, comma, select your appropriately matched size X matrix, Control Shift Enter, and we get that array in there. Then we can do here the same thing. It's now the cost vector times this. So this is going to be equal to mult this, comma, this, enter, and we get the price. And I'm going to color this bold. I'm just going to format cells, currency, okay. And this is going to be okay. There we go. So now that we have this all set up, it's just doing the same thing we did before. Solver, objective, okay. We go to the solver here. We tell it that we want the, our objective function to be the total cost. We're going to minimize it by changing the cells these. Let's delete the prior constraint that was there, but we're going to add our constraint. Our constraint is the same thing from before. All of these have to be less than or equal to all of these. Okay. Solve. And we get the same answer as we did before. And so say OK. And here we can just go ahead and go to Format Cells, Font, or number, Format Cells, number. Okay. And that is, in a nutshell, how you do that's how you do your linear programming. It doesn't really matter at this point what it is you're optimizing. It doesn't matter whether you're doing it at cost, total intake, time. As long as you have some value that you're going to minimize or maximize, and you have constraints of other variables that you're trying to work within, if you can set up a series of linear equations to describe that, you can use linear programming to find an optimum value for your solution. And this is exactly how you do it. So hopefully this is makes sense, and I'll now go on to macros. Thanks a lot.